going to solve a bunch of exponential equations. I'm going to start with a simple one like this, and then hopefully it will become increasingly irritating. The first thing I'm going to do is subtract 4 to the other side. Get all of the constants on one side. This will be equal to 10. Divide both sides by 3. Now I can take the log base 4 if I want to, but most calculators do log base 10 or natural log. And in this case I'm going to do natural log because it's one less letter for me to write. Take the natural log of this side and this side. Use the power rule to bring this down. Divide out the natural log of 4. Now I add 1. And divide all of this by 2. I'll be left with x is equal to the natural log of 10 over 3 divided by the natural log of 4 plus 1 all divided by 2. And this would seem like an inconvenient way of writing it, but really all of this is going to be going into a calculator and coming up with a decimal approximation. And that's why it's useful to use natural logs as opposed to log base 4, although log base 4 would seem to be more logical. And the reason I wouldn't use log base 4 is simply because in a calculator I would end up having to use the change of base. And here I can recognize that this is the change of base. This is a base of 4, and then the x is 10 over 3. So let me do another one. I'll do (3) to the 2x minus 1 is equal to 2 to the x plus 1. So this is another relatively simple one. Here I can take the natural log or the log base 10. I do the natural log because it's one less letter to write. And I will bring the powers down. So the natural log of 3 to the 2x minus 1 is equal to the natural log of 2 to the x plus 1. I use the power rule. These powers come down in front to the x minus, or 2x minus 1, natural log of 3, x plus 1, natural log of 2. Now I need to distribute these natural logs, multiply them out, so I can get the x terms, subtract all the x terms onto one side, get the constants on the other side, and then continue on from there. So this will be equal to 2x natural log of 3 minus the natural log of 3 is equal to x times the natural log of 2 plus the natural log of 2. I need to get all the x's on one side, factor out the x, divide out, and I'll have my answer. So I'll subtract this term over to this side, and I'll add this term over to this side. 2x times the natural log of 3. I subtracted this term, minus x, natural log of 2. I added this term to the other side. Yeah. Natural log of 3 plus the natural log of 2. And now I simply factor out all of this. I just factor out an x so I can divide the rest of it out. So if I factor out an x from here, this would be x times 2 times the natural log of 3 minus the natural log of 2. Now I divide this term out of this side and I divide it over to the other side, and then I'm left with what my x is equal to. And this is my final solution. And again, if I wanted to find an approximate value for this, I would simply put all of this into my calculator and it will give me an approximate value for it. So let me do another one. I'll do a few more. Five over 2 plus base 3 to the x is equal to 4. So the first thing I'm going to want to do is remove my x from a denominator. So I'm going to multiply this to the other side. I'm going to multiply both sides by 2 plus 3 to the x. And it will give me 5 is equal to 4 times 2 plus 3 to the x. And this is equal to 8 plus 4 times 3 to the x. And now I go about simplifying this. So I have a constant of 8, I subtract that. Minus 3 is equal to 4 times 3 to the x. And already here I can see that there is going to be no solutions. I can still simplify it a little bit more, but I already know that this is going to have no solutions because it's impossible. So I'll divide the 4 out. And I get minus 3/4 is equal to 3 to the x. And if I ask myself, a base 3 raised to what power is going to give me a negative number? There aren't any, because if I raise this to a positive power, I'm going to get a positive number. If I raise this to a negative power, it's going to give me a positive number, but just a reciprocal, 1 over whatever. It would just give me a very, very small number. So there are going to be no solutions. Or I can write it like this, which means no solutions, or an empty set. Now let's move on to base 2 to the x minus 4 times 2 to the x is equal to 21. Now here's a problem where I can make a substitution. I can substitute 2 to the x with y. And this will make this problem much simpler. If I replace 2 to the x with y, I'm going to get y squared minus 4 times y is equal to 21. I can now treat this as a regular quadratic equation. So two numbers that multiply to be 21 and add to be minus 4 be minus 7 and positive 3. y is equal to 7 and y is equal to minus 3. Now, I resubstitute in this. So I say 2 to the x is equal to 7 and 2 to the x is equal to minus 3. And here I can see that this one is impossible because there is no power of 2 that is going to give me a negative number. Not possible. So this is not a solution, so I only have to worry about this one, and I can just take the natural log of both sides. Natural log of 2 to the x, natural log of 7. Use the power rule. X comes out in front. Natural log of 2, natural log of 7. Divide both sides by the natural log of 2. X is equal to the natural log of 7 over the natural log of 2. So that's that one, and I'll do one more. This one will hopefully be a little bit tricky. Maybe it will be, I'm not sure. It looks tricky. And it was one of the last problems. So e to the x minus e to the minus x. Ew. E to the x plus e to the minus x. And this is equal to 1/3. So I have minus x's, all the same base. For me, what I would do first is just multiply the top and bottom by e to the x to get rid of the e to the minus x's because they're kind of annoying. So I'm going to multiply, I'll do it in a different color. I'll multiply the top by e to the x and multiply the bottom by e to the x, so that the value of the fraction is still the same because I've multiplied the top and the bottom by e to the x. If I multiply the top and bottom of a fraction by 2, it's still the same fraction because I can factor out e to the x or I can factor out 2. So if I do this, I'm going to get e to the 2x minus e to the 0. E to the 2x plus e to the 0 is equal to 1/3. And e to the 0 is 1. Alright, e to the 2x minus 1, e to the 2x plus 1 is equal to 1/3. And now I guess it would be easiest if I made a substitution. I'll substitute e to the 2x is equal to y. So I'll make the substitution, and I'll get y minus 1, y plus 1 is equal to 1/3. I can multiply this over to the other side. So I get y minus 1 is equal to 1/3 y plus 1. Distribute that. Y minus 1 is equal to 1/3 y plus 1/3. Now I get all these terms on the same side. So subtract 1/3 y over here, add 1 to the other side. 2/3 y is equal to 4/3. Multiply both sides by 3/2 to get rid of this fraction. So that'll give me 12/6, which is 2. So y is equal to 2. Now, I substitute this back in for y. And I get e to the 2x is equal to 2 take the natural log of both sides. Natural log of e to the 2x is equal to the natural log of 2. Use the power rule, bring the 2x down. And the natural log of base e eliminates itself. So 2x is equal to the natural log of 2. Thought I did something wrong for a second, but I didn't. I was just... Did I? No, I didn't. Of course not. I would never make a mistake. So now I divide both sides by 2. X is equal to the natural log of 2 over 2.